Okay, so this tutorial is solving equations, excuse me, involving integers. So the last tutorial we were solving equations, modeling equations, using the balance sort of metaphor, and the left side of the equation balancing to equal the right side of the equation, and then using that to solve the problem. But you may have noticed that it was always this kind of problem. The constant was always positive. So when we're talking about integers, we're talking about the set of positive and negative numbers. So how do we do that with negative numbers? What could we use to represent negative numbers? Let's go look at the other app, the old applet we looked at. Okay, so this one was our very basic one, x plus 1 equals 7. Okay, and this is tedious drawing out 7. Oh, here we go, come on. There, so it's balanced out. And that's very easy. What happens though if this was x minus 1 equals 7? How could we possibly show that? X minus 1 equals 7. Well, I can't really show a minus 1. What would be a minus 1 here? So this applet won't quite work. We're going to move on to another applet. So here, as I promised, I changed it to x minus 1 equals 7. This is the new applet that involves a couple extra little things. So here we have the brick, the variable brick, unknown weight, and a 1, let's say, gram brick. And we've added two things on here, helium balloons. So let's see how that works. If I drag over one brick onto this side, the left side of the balance goes down. And if I drag over -1 helium balloon, what happened? It completely counteracted the weight of the brick. So this represents +1, the balloon represents -1. Okay, let's see if I drag over another balloon. Now you can see it's pulling up, it's over this one, and this one cancel out, but it's got a negative pull. It's lifting up the left side of the balance. How would I zero that out again? Put down one more brick. And so here we can do this to model an equation with a negative integer. And you might be saying, hey, hang on a second, isn't x minus 1, isn't this a positive integer? X minus +1 equals 7? That is true, but we can always think of subtraction as adding the opposite. So what's the opposite of subtracting +1? It's adding -1. So that's how we're going to model it. First thing is 1x, drag over an x, and -1. Subtract 1, that's going to be represented with -1 balloon. Then on the right side we have +7. So we can put 7 bricks, 2, 3, 4, 5, 6, 7. It balances out. Okay, so now my job in algebra is to try to isolate the variable so that I can find out its value. What's keeping this from being isolated? It's not alone. It has a balloon hanging off of it. What can I do to neutralize or get rid of that balloon so I can get x by itself? Well, I can add in a positive brick to both sides, and then it would be equal. Okay, it would be balanced. And this is going to be negated. -1 is just eliminated. It's called a zero pair with the +1. And we'll find out that x is equal to 8, which you can all see 8 minus 1 is equal to 7. But let's demonstrate that. I'll model it properly first and do it the way that they want me to do it on this applet. I've modeled it, x minus 1 equals 7. Continue. What do I want to add to both sides? Or subtract, or multiply, or divide. In this case, I just want to add 1 to both sides, and there we go. I get x equals 8. Okay, so here's another problem. This one's got a negative integer on the right. The left-hand side here, I have 2x. So I'm going to drag out 2x. And I have +3, 1, 2, 3, so we're adding 3. This represents 2x plus 3. And over here on this side, I have -1. So it's balanced, so I know that I've modeled it correctly. And now I have to go about solving it. So my first job in algebra is to try to work towards isolating the variable. The variable's on the left side, but it's not alone. I don't have x's by themselves or x by itself. So I got to get rid of this stuff. So how do I get rid of it? You might say, oh, you could just take off the 3, but are there 3 positive bricks for me to take off over here? There aren't, so I have to think of another way. What can I do to eliminate this push down that these 3 are exerting? I can put in 3 balloons. 1, 2, 3. And if I put them over here, 1, 2, 3, you can see that that balances out. Okay, now I'm going to get rid of those because the applet wants me to not do it that way. It wants me to type it in. So I'm going to go back to what I had it modeled as. 2x plus 3 equals negative 1. I'm going to go continue. What is it that I'm adding to both sides? Negative 3. If I add negative 3, that 3 balloons, that'll wipe out or eliminate or nullify these 3 here, and I'd be left with 2x. And over here, I'd end up with 4 negative balloons. So we'll go. There we go. So we're getting closer to solving it. Now we have a new equation that's shown here. 2x is equal to negative 4. So now I have to look at it and say, all right, I've got 2x here, and on the right side I've got negative 4. If I divide this into 2 piles, how much is in each pile? 1x. If I divide this into 2 piles, how much is in each pile? Negative 2. I'm dividing both sides by 2, and there we go. There's my answer. X is equal to negative 2. We've done it. So that's the solution. Okay, what about this problem? So I've got 3x plus 5 is equal to negative 1. I'm going to model the left side. So 3x, 1, 2, 3. And then I also have positive 5 plus 5. 1, 2, 3, 4, and 5. On the right side, I just have negative 1. Okay, so what can we do to solve this problem? What am I going to do to isolate x? I've got this stuff in the way. How can I get rid of it? What should I do? What if we add to both sides negative 5? How did I get that, you might ask? Well, there's positive 5 over here with x, and I want to wipe it out, so I'm going to add negative 5. So I'm going to go. And there we go. Now we have on the left 3x, and on the right negative 6. And our new equation is here. So what can I do now? Well, I can see if I divide this into 3 groups, how much is in each group? 1x. Divide this into 3 groups. How much is in each group? Negative 2. So your last, if you have multiple x, if you have 2x, you can divide both sides by 2. If you have 3x, you'll divide both sides by 3. If you have 4x, divide both sides by 4. But if you have negative 3x, divide both sides by negative 3. That one won't come up in our simple problems. So I'm going to divide both sides by 3 and go. And there we go. My answer is x is equal to negative 2. Now what are you going to do if you don't have an applet and it's a pain to draw scales and balances every time? Trust me, I know. We can show it another way. That's what I'm going to show you now. Okay, what if I have a problem like this? X plus 5 equals negative 6, and I don't want to draw blocks and balloons because that gets to be a drag. I'm going to represent this with little tiles, okay, like we did before, integer tiles. We're going to have a white one, in this case not colored in, is going to equal positive 1, and a dark one shaded in equals negative 1. Okay, so how can I represent this? If you recall, when we used integer tiles, we used this squiggle to equal sign. And then over here on this side, what can we do to represent x? Well, we can borrow the idea of the rectangular prism or brick we had from the other one. This is going to be equal to x. And what would be a dark shaded one? This one would be equal to negative x. Okay? So if it's rectangular, that means it's variable. So we're going to go ahead and put 1x in there. And we have to put positive 5. So 1, 2, 3, 4, 5 is equal to negative 6. So I got to put 6 of these shaded in bricks. 2, 3, 4, 5, 6. Shade them in. Oh, this is a hassle. Okay, and now we can solve this using algebra tiles. So if I had that app up where I had balloons, these would be like bricks, these would be like balloons, and so I have to figure out a way to get rid of the bricks. So what counteracts the bricks? It would be balloons. But in this case, they're negative, the negative tiles are just shaded tiles. Okay, so I'm going to add in 5 shaded tiles here. 1, 2, 3, 4, 5. And I have to do the exact same thing to the other side. 1, 2, get sloppier as I go, 3, 4. Look at that, no longer even squares. Lazy. Okay, so now I have a new equation. I've done the same thing to both sides. I added this, and I added this. Okay, so that kept it balanced. Just think of it as a balance, it's still balanced. Oops, that's not what I meant to do. How'd that happen? I have no idea. Oh, did it again. Okay. So now what I have to do is think about what's zeroing out over here. I've got this one and this one will cancel out, this one and this one will cancel out, this one will cancel out this one will cancel out this one, and this will cancel out this one. I've done it. I've gotten x by itself. Is anything canceled out over here? No. So that means my answer is x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. X is equal to negative 11. And there's my answer. Okay, what if I have this problem here? I'm going to represent this with tiles. I'm going to do 4 rectangular tiles. Well, those are looking good. Ugh. And my squiggle, that's for the equals. And 5 positive integer tiles. And then on the right side, 3 negative integer tiles. I should have done that in black. 1, 2, 3. Okay, so think of this as a balance. Over here I've got the 5 or the 4 variable tiles, and I've got 5 positive tiles. These are like bricks, and over here I've got like 3 balloons. So what am I going to do to get rid of these bricks? Because I need to isolate the variable, get it by itself. Solitary confinement for the variable. So I'm going to put in balloons, or because we're not using balloons anymore, what's the opposite of bricks? It's going to be these negative ones. So I'm going to add 5 negative ones to each side, to both sides. Okay, and then I'm doing that. I have to do that over here. Alright, so have I done that? Wait a minute, I got lost. Oh, not quite. Okay, I've added 5 negative ones to each side. So what happens? These cancel out, boom. Cancel out, boom. Cancel out, 0 pairs. They're zeroing out. And now I have a new equation. 4x is equal to negative 8. Okay, now I can simply solve this by division. And you can see it here. You can see it very clearly. If I take another color pen here, draw a line through this. Remember doing this. Okay, this shows me very clearly. If I divide this into 4 groups, I get 1x in each group, and if I divide the 8 into 4 groups, I get negative 2 in each group. So my answer, really what I did was divided by 4. My answer is x is equal to negative 2. And that's that. So now, I'd like you to try a little quiz, and it'll be easier than this example, and it'll involve some pictures. It should be lots of fun. See you there.